Oh, now it is. Now it is.
Okay, someone's recording.
Yeah.
I just got a prompt. It asked my permission.
Yeah, it's recording now on my end, I think, for one thing.
Okay, let's go then. So the main thing to know is that the instructions for building the triple cones comes from Mike's paper, which is on academia, and it's called Triple Cones Cancel Vac Symptoms. So anyone wanting to build the cones, it would be wise to go to that paper first and having a copy, because that actually gives all the information. I was able to build them very successfully just from the information there. But what I'm going to do today is just go through the practicality of it, because there are certain things that can be simplified when you've done it on a practical level. So initially, Mike was saying that the first triple cone would be built using one of these paper cones. So I actually did some of those. There's one of them. But later, it was discovered that the pine cone model was a more powerful version. So the pine cone molds, there's one of them there. They're easily available. They're actually baking molds, but they're rubber and they're easily available. All of this stuff is very easily available off the web. So what I'll do to begin with is just explain the mixture. So to actually create the mixture for each of the 3 cones, the basic cement that I use is this one, which is this is from Screwfix, and it's called it's just rapid set cement. And most towns have a Screwfix, and so you can actually pre-order the cement online. A tub like that comes with 2 of these bags, so that's actually ready. So the 3 ingredients for the main composition for each of the cones is the cement I've just shown you. The second one is the iron filings. So the iron filings, the best kind to use are from a machine shop. So if you ask for filings, the smaller they are, the better, really. And the ones that I use, there's a local machine shop, and they do quite a lot of drilling. So it's the swarf that comes from the drilling rather than from lathes, because the material is just much finer. So that's the second ingredient. I'm going to show you the most basic form of triple cone, and there are ways to improve on this, which are referred to in Mike's paper. So the power can be enhanced by the information. There are links in Mike's paper which show how you can enhance things, but this is the most straightforward way, so you can get building them straight away.
David?
Yeah?
I've got a couple of bags of postcrete. Do you know if that would work?
Postcrete wouldn't really be refined enough to do the triple cones. Postcrete is okay for the first kind of bubble pieces, which are cast in a bucket, but because the surface of the cone needs to be quite fine, the rapid set cement is far better, because when it's cast, you get a nice smooth surface, whereas it would be a rougher surface if you use the postcrete.
Oh, okay, thanks.
Okay, what we'll do, I think, is I'll just go through. There are 3 stages for each, so a stage for each of the cones. If we can just keep to the instruction until the end of each section, and then we can raise any questions, and that's probably going to be the easiest way to do it. So the water that I use, I mean, this is just a small sample really, but this is crystal water. So crystal water is it's local spring water that I use. There's a local spring, and I go along there with some containers and I get the water. And then I like to stand the water in a glass vessel rather than a plastic one, and put some clear quartz crystal in there. I tend to leave it for about 2 weeks, and then the water's ready to use. So, you know, you can have several bottles or you can have bigger flagons and things, but that gives you the crystal water. You can use Gans water, which is, that's a more elaborate process, really. But you can get underway with this, and the power of them just using these simple methods is pretty profound, really. So,
Moment. Actual GANs is a really good idea to put in the goodies because it's microtubules.
Right.
And it creates piezoelectric spins the same size of our DNA.
Okay.
You know, and it's superconducting. You know, that's why it works. You know, the superconducting energy in GANs is what causes it to be healing and do what it does. So any of that kind of life force energy, which is superconductance, that we can get, is the better. GANs water, kinda. I would suggest it's too easy to make colloidal silver water, and you can do it like that, you know, and it's cheap, and you know, and although that crystal water you use is ideal, you know, some people are going to wait 2 weeks, whereas the colloidal silver water, you can make it quite quickly, you know, and doesn't get much better than that. If you have little GANs in it to structure it, that's cool. But a crystal will do that, and also more usually, the piezoelectric energy is what does it, and having dissimilar metals wound together. You know, like we use copper and zinc BBs, and where the two dissimilar metals touch, there's a potential difference there between the sizes of the crystals in each metal. And that creates eddy currents that's the same thing what GANs does, you know, as well as crystals, only much finer, you know, at the crystalline size, and the smaller we can get, the better. And that's about the quickest and easiest to do is two dissimilar metals wired up, preferably in a tensor ring, you know, but it doesn't matter, you know, you just put that in with the goodies, and you've got a forever source of piezoelectric energy.
Quick question: how do you make Gans water?
That's a more elaborate process, which is beyond the scope of this meeting, really, Craig.
Okay.
I just need to look that up. There are demonstrations. I think there are links from Mike's paper, but there's definitely information on YouTube.
Okay, good. Yeah.
Okay, good.
All right.
So the mixing of the material, all you really need is a builder's bucket like this one, and I found the best tool to mix it with is a fairly robust scraper like this, because you can mix it pretty thoroughly with one of those. So you initially add the water. So the water goes in first, and it's better not to overdo it with the water. So probably, you know, just having maybe, well, it depends on which process you're doing. If you're going to do the first process, which is to do the eight pine cone molds, probably half an inch of water in the bottom of the bucket would be enough. And then the ratio of the cement to the iron filings it's 30% of the iron filings to 70% of the cement. So the iron filings go into the water first, and then the cement is added gradually. When you're adding the cement, it's quite dusty, so it's worth wearing a mask like this, or even some, you know, you could wear some eye protection as well. And so the consistency of the mix needs to be, it needs to be able to be poured, but only just about. So it's a similar consistency to builder's mortar, really. And by putting the by putting the mixture into the molds. So the mixture, once it's mixed to the consistency of builder's mortar, these 8 molds would be filled to within about 2 centimeters of the top. So you leave the 2 centimeters to be able to get the goodies in. So the goodies are the ones which are listed. So it's magnetite, DNA material. So actually household dust is quite a good thing, because a lot of that is from the human body. But diatomaceous earth, shungite, some soil, local soil from outside, graphite, honey, and cannabis. And most of those are in the form of powder, so they can just be mixed together. So you mix enough together, and it's a very small quantity, really, and you just mix that together, ready, and just enough to do the first 8 with the molds. And then Mike mentioned to me a method which has been great, actually, which is to use steel wool. So steel wool enables you to create a base onto which to put the goodies. So once the mold is filled to within 2 centimeters of the top, the first piece of steel wool goes in and is pressed into the cement, and then that forms the basis on which the goodies can be sprinkled. So that mixture of dusty granules and things is sprinkled onto the steel wool. And then I usually add a small piece of quartz crystal, a piece of amethyst. I sometimes put a little piece of shungite in there as well, and I have the quartz crystal pointing at the amethyst. And then once you have those, they're kind of embedded in the mixture of materials, in the sort of dusty mixture. And then it's just a matter of putting another piece. I put another piece of the steel wool on top of the goodies like that to protect them. And because Mike was saying the steel wool actually amplifies the effect. So putting the steel wool on, like I said, the steel wool is just, well, I've got some here. You know, you just buy steel wool like this from a hardware shop, and it can be cut with scissors, because you're doing it with quite small areas.
And if you put copper or zinc BBs in that steel wool, there you got another source of piezoelectric energy. Yeah, just another trick.
Yeah,
tricks are for kids. We know we got some.
Yeah, great. Okay, so we'd have the goodies in, and then it's a matter of just using a bit more of the mixture that we already have to top the molds up to the brim then, and we just smooth them off. You can just smooth them off with the back of the scraper, and then you just put them on the surface. I just usually leave them on the draining board by the sink, and you just leave them there. They probably need 3 hours minimum, but sometimes you can leave them overnight. But they would definitely need 2 to 3 hours. And then they
sorry, David.
Yeah.
Another point is that the mix should be pretty wet. Okay.
Yes.
And as opposed to, you know, what those concrete finishers used to call the sea level slump. You know, it's where it goes level when you pour the concrete out, as opposed to being stiff.
Yeah.
And the reason is that as you get a better set on the calcium silicate that's produced during the chemical reaction, and the water fuels the chemical reaction. And so the more water, it sets harder, you know, to begin with, and it's more brittle. You know, so it's not structural in that sense. We don't want it structural. We want it hard and brittle, you know, because then it shrinks onto the goodies and the crystals and so on and so forth. So that happens, you know, much quicker That's
Yeah.
why that's how that quickset cement is set up to be used.
Yes. The main thing though is not to have too much water, because with too much water,
Yeah, right. Yeah,
the
correct.
water
Yeah, you gotta be
rises to the
careful.
surface, and it affects the strength of the mixture. But it's just trial and error, really. But it's you know, as a guide, you want it so that it'll actually pour, but you want it so that it doesn't pour like cream. You know, it kind of pours slowly. And then what I just use a paintbrush like this, and once you put the mixture into each of the molds, sort of prodding it with the brush consolidates the concrete. They do this on building sites. They have these concrete pokers, and it's basically to get the air out of the mixture. So if you get a paintbrush and you put the mixture into the molds, and then you sort of, you know, poke it a few times with a paintbrush, that ensures that the mixture fills all of the mold, and then you get a nice clean mold with no gaps in it or anything. So at that stage you would have 8
It's called a vibrator. You may not be familiar with those.
Yeah. Well, only the ones that they use on building sites. So this I thought the biggest problem with this this conversation is going to be trying to keep a straight face with Mike on here. Okay, so let's try to be serious again. So you'll then have 8 of these molds, which is the first stage, and then so the next stage is to actually coat them with the resin, so that they look like this. And to coat these cones with the resin, you don't need to worry about doing the bottom at the first stage, because the bottom of the 3 cones can be done at the same time. So this one, what you do is you buy some, it's called Regal floor paint. There's the tin I've been using. It's called, yeah, Regal floor paint. They're based in Stafford in the UK. So you have a 5-litre tin of paint like that, and then you have the activator, which comes like this. So it's a ratio of well, it's 20% of activator to you know, to the mixture for the 5 litres. So it varies slightly depending on the weather, because the activator, if you're doing it in the winter, for instance, it's going to be a longer process than in the summer. It tends to go off more quickly in the summer, but it's pretty easy because you've got the 5 litre. You know, basically what you have to do, there's the 5 litre tin, and then there's the mixture. So the ratio is pretty straightforward, really. Okay, so the way you mix that is you'll need some gloves. So I just have an ordinary pair of gloves like this. I do the coating of the cones outside. If it's a fine day and you know it's not going to rain, then you can just do it outside. I actually have a table with a parasol over it, so that if it's likely to rain, you can just put the parasol up and keep the keep the cones dry underneath. Because if the cones are coated and then they're rained on, then you'll need to do them again, because it disturbs the activation of the resin. So the resin, actually, it needs to be fairly small quantities. It goes quite a long way, and you just need a container like this, a plastic container, and so you mix the resin well, actually, you stir the resin first. So you stir the resin in the large 5-litre tin to make sure all of the material is evenly distributed. And then you pour some of the resin into the container, and then you add the correct ratio of activator. And when you're doing this, it is worth wearing some protective eyeglasses, some gloves, and also a face mask, because the fumes from it's fiberglass effectively, so it's it's pretty ferocious if if you breathe too much of it. But if you're outside in the open air and you've got a mask on, it's absolutely fine. So you mix enough in the container. So to do the 8 of the pine cone molds is actually quite a small quantity, and then so the way you coat them is you buy some brushes. They have these, probably seen these brushes. They're quite cheap, really. You have a sort of 10 brushes for £5, and because the brushes can only be used once, so you buy these cheap brushes, and then you just use them once, and then just wrap the brush in some kitchen roll and put them in the bin. So the way you coat them is, so you'll be wearing gloves, and then you just dip the brush into the mixture, and initially it's good to just paint the bottom kind of inch of the cone like that, so that you've got the whole of the bottom area coated, and then you can actually stand it up on the table. What I tend to do, I use usually a bin liner, and I open the bin liner up, spread that on the table, and then as I coat the cones, you coat the bottom of them first, and then you place it on, and then you can finish it off once it's sat on the table. And it doesn't matter if the resin drips down onto that bin liner, just like a piece of thin plastic. The thinner the better, really, because you can just pull it off once the resin's dry. So you just coat the 8 of those. Usually leave them for 24 hours to dry. Sometimes they take a little bit longer than that. And then that's the first stage done. So that's the
David,
yeah.
is this not the amplification layer with the iron oxide in it?
Well, yeah, the iron oxide is added on this amplification layer. Yeah, it is.
And so don't you mix that in with the resin when you
Yes,
paint it?
yes. Yeah.
Oh, I see. Okay, yeah.
So
Yeah, so it's about 50-50 iron volume wise, resin to iron oxide plus some binized sand, or
Yes.
well, that's it, binized sand.
Yeah.
Binized sand is phenomenal. It doesn't take very much.
Yes.
Teaspoonful, that's it.
Yeah, exactly. You have to just be careful in the things that you're adding to the resin, not to weaken it, because otherwise it can break down the process.
Yeah, well, that's standard. When they put resin floors, they put aggregate, because the resin itself, if there's all resin, it's expensive, so they put broken glass in floors.
Yes,
they're really quite amazing.
Yes.
What's the name of that sand again?
Bionized sand is sand that has been frozen and thawed 3 times, and Wilhelm Reich did that, and it starts emanating this blue light as a result. The way that we prefer to do it, especially for the pine cone part and the goodies, is to take our best source of sand, which is normally whatever local sand, and then put it in a mortar and pestle and grind it up really fine, and then bionize it.
Yes.
That's the ideal bit of sand. See, crushing the sand puts a stress on the crystal, but bionizing it takes the stress out of it and makes it phenomenal, really.
Yeah. Great. Yeah. Well, that's
all these things create spin energy, and that's going to harmonize with our DNA, all DNA.
Yes.
And it blows the loche out of our ass. You can see it leaving.
So yeah, putting some additional DNA into the goodies is a good thing, like putting some hair in or something like that. But
hair's big time. It's our DNA. It connects to it's our DNA.
Yes.
And so it blows the lotion out of the DNA
yes.
in our entire body. And it's somebody pointed out, not myself, but it's a big assist for telepathy.
Yeah.
Yeah. Got to get rid of the brain damage in our DNA.
Yes. Brilliant. Okay, that's great. So yeah, but really, the technicalities and the sort of refined details are in Mike's paper. What I'm trying to do is just to steer people through the process of actually building them, so that there's no trepidation. That it's just a very easy process. So so once you have the 8 of these cones with the layer on them, then you're ready to go with the next stage, which is the second cone, which is these. So as Mike says in the paper, these cones, that they're used for kids, really. They're mainly for playing football. You sort of set them up in that way. But so you get the smaller cones. What I do, I use this is damp-proof membrane, which is it's just really thick plastic, and you just form this to go into the cone, and that means that when you come to take the cone out, once it's set, it comes out easily. If you try to set the cone in this plastic without any lining, it sticks to it, and then you can only use the cones maybe once or twice. So excuse me, getting some damp-proof membrane, which is just thick plastic, you can get it from builders merchants. You just form that kind of insert, and then what I do, I just use cling film. So you just get a piece of cling film, and you put the cling film onto the thing like that, and then put it inside, and then when you pour the concrete into there, pour the mixture into there, then that keeps it so that it's very easy to remove once the concrete or the mixture is set. As you can see, I've put a piece of insulating tape on the join in that plastic, because if you don't do that, you find that the mixture seeps behind the plastic, and then that distorts the cone. Whereas if you just put that piece of and this applies to this second cone and to the outer cone, with the insulating tape like that, it just seals the plastic, and then you're ready to go again. So the way I do these, I actually just use a large plastic jar. You probably heard one of them break a few minutes ago, but if you have a jar like this, it's just like a pickle jar, really. And if you put this on a level surface, then you just have it ready to put the material in. So to do the second one, you have the first cone at the ready. You do the mixture as you did before with the 3 components. So you have the cement mix, you have the iron filings, and you have the water, the crystal water, or whichever water you wish to use, mix them together, and then this time, so you put some in. I tend to sort of fill it up half first of all, and then again prod it with a paintbrush handle just to get it to compact into the shape of the cone, and then top it up. But you top the cone up to within probably half an inch of the top, to allow for the displacement when you push the first cone in. So you'd have the cement up to here, have the mixture up to here, and then you want it so that as you drop the cone in, that it just sits level to the top of the cone.
Yeah, you want the one with the amplification layer on it. That's a rock. Yeah.
Yes.
Okay.
Yeah.
Yeah. The pine cone with the amplification layer on it.
Yeah. Okay. So again, you can actually, what I tend to do with the center cone is I usually cast 2 of these at a time. You can actually have maybe 2 or 3 of them set up. If you have a few of these molds like this, you can have them set up so you have the DPM insert in there ready so that it can be used. And then it just means that you don't waste the mixture, because you can just cast the 2, and then if you have some left over, then you can do, say, a third one as well. And so you can do with the middle ones, you could probably do 8 in a day if you had if you were going to devote the whole day to doing them. So yeah, you'll just leave those once they've been cast and the the pine cone has been pushed into the top. Then they can just be left to set for 2 or 3 hours, and it's quite good.
Okay, let me insert this point, please.
Certainly, yeah.
All this technology was given to a shaman named Bubba, and then I put it into physics. And the thing is that we're working with the ethers, and and the cone connects to all kinds of ethers, yeah, to the shape. If you can imagine, different etheric realms are different size, and you got a cone poking up through there. It's going to fit perfectly with a number of them. So the other thing about fitting perfectly with the ethers is the actual physical size of everything, but in particular these cones, you want to fill your etheric cell as full as possible, so that, like honey, there's no loche that gets in around the edges. Okay, because that's where loche can travel, is in the edges,
yeah,
in between the physical thing and its etheric cell. And the anu is the physical thing. Everything has an anu around it. So all of this adds up to having precise sizes of things.
Yes.
The Joe cell is a very good example of that. But precise sizes, the amazing part is this is a predetermined technology, because those cones that you've got there that are cheap and commercially available are the exact right size, 9 inches.
Right. Yeah. Same
with the pine cone forms from Amazon. The silicone pine cone forms are 3 inches. It wants to be a little bit more than that. 3.3 is ideal, but 3 inches is really fine. And then the next one, the final one, the large one, around 14, 15, 16 inches is, because you're going into larger ethers, and you've got they adjust in size, and then you also into the larger swarf in the third layer, the third cone, so that you're literally dragging the really fine information out of the pine cone and broadcasting it into all etheric realms.
Yes.
This is why the cone shape is so powerful. and the plasterite people use it. And I think Ed Lee Scallon, the Coral Castle guy, had some kind of a cone-shaped antenna that broke gravity on 20-ton chunks of coral. Now, I don't know how that works, but that's it. So the cone shape is a big deal.
Yeah.
And particularly being in the perfect harmonic size with the etheric realms that we're connecting up with to do our intentions. That's how our intentions get, first of all, established in darkness, like everything is. It's the smallest, finest level. And then it expands and grows as the ethers grow.
Yeah.
And then our ideas grow until they pop into the hexagonal ethers where they're made manifest.
Yes.
So there's four-sided ethers right outside of darkness, and ideas come out of darkness, get installed into the four-sided ethers, and then they broadcast up. We do exact same thing with these cones.
Yeah.
No. Yeah. So we're just working with the ethers.
I got a question on the four-sided thing, is whether a pyramid shape could be better than a cone, or is the rounded?
Absolutely not. Absolutely not. Not what most people think was a pyramid, i.e. the five-sided pyramids, like Egypt.
Yeah.
They focus, they're good for focusing energy, but we want to broadcast this energy. We don't want to focus it.
Okay.
Our tetrahedrons that we use for the Merlin's chamber are a delta T antenna. They're chaotic. It's chaotic energy. It's the triangular ethers are amazing in that any size works. As long as the equilateral triangle, it works. And so they're chaotic, and more proof of that. And so where they come from is obviously the first idea of time went into the ethers, and it made a triangle. And so even though time seems logical and coherent, in this case, it's so close to darkness and chaotic darkness, the chaos comes along with it. Herself. She provides that chaos. Yeah. And so the tetrahedrons of the Merlin's chamber and the tetrahedrons in our body cell water and the tetrahedrons in our bones all line up, and energize in a Merlin's chamber, especially with these triple cones properly made, set around the corners of the Merlin's chamber. But those triple cones are not necessary. Any organic thing will work. It's just in a triangle. You can do it on a slab. You can take a violet ray wand, poke 3 holes in an equilateral triangle on a concrete slab, put the wire into it and wire it to the violet ray wand, and you'll have yourself a very usable Merlin's chamber. However, the ones that we're doing are interdimensional doorways or delta T antennas. The big tetrahedrons with the pipes and everything set up properly. Those Merlin chambers are really phenomenal.
Great, thank you.
Okay.
I just had one practical question.
Yeah.
So when you push the pine cones in at the top, you do it upside down, right?
Yes.
So the top, so when you turn them back up, the top is facing up.
Yeah, that's it. Yeah.
Okay. All right.
And how far do you push?
You push them so that the bottom of the pine cone is level with the finished surface of the second cone. So it's just so that you have well, as it is with this, that's the base of a triple cone. So whether you can see the 3 cones in there, but so the idea is that the base is going to be even. So
yeah, excuse me, David, sorry.
Yeah.
A better idea, my friend, would be
Yeah.
to push it further into the cone.
Right.
So it's got a good bit of concrete all around it that squeezes it. That's what we want. That's
Okay.
what, that's how we get the juice out of the pine cone.
Okay.
So I would put it further in, into the middle of the pine cone.
Great.
I mean, the next cone, the pine cone will go further into the second cone.
Okay. So and then yeah, it can be covered over. And does that apply to the second cone into the third cone as well, Mike?
Yeah, of course. Yeah, because you're getting it's like feeding one turbocharger with another.
Yeah. Yeah. Great.
You're gonna create some pressure, and
Okay.
that's what we want. This pressure to squeeze the goodies and all of the sand, the bionized sand. Really phenomenal.
Yeah.
Yeah.
Okay, so yeah, that's an amendment then. Just to push them in a bit further, really. So yeah, when
sorry to interrupt. Is the bionized sand part of this mixture that you're putting in the second cone, the 9-inch cone?
If you want to make real powerful ones, you use always bionized sand.
Yeah.
It doesn't have to be all ground up with mortar and pestle. Especially after you get the third one, it can just be sand off the beach. You're freezing thaw a few times.
Yeah. Great. Okay, so yeah, then you have so you could actually cast 8 of the second cone with the 8 pine cones. So then you would have those 8 ready to be coated with the resin and then the amplification layer. So the amplification layer, do you recommend that on each of the cones, Mike, on the 3 of them?
Yeah.
Yeah.
Don't you?
Yeah, I do.
Yeah.
Wanted to check that though.
Yeah, that's what makes it work. That's the big trick to the triple cones.
Yes. Okay. So similar process then. So you just mix the resin and the bionized sand in a container. You get it, so that it's the right consistency, and then again you coat it outside. So you'd use a bigger brush for the second cone, and then you coat the bottom half of the cone, and then stand it up, and then finish coating it when the cone's the right way up. And then you just have those placed on a table outside. Put them on a piece of plastic or something, as I mentioned, like a bin liner, which is quite flimsy. The main thing to do though is make sure that the corners of the bin liner are weighed down, because you don't want the corners to be blowing up in the wind and then sticking to the pine cone as it's going off. So you just coat them in that way. So yeah, the second one will be coated, and so you could either do 4 or you could do 8, depending on how much time you have. So you'd then have you'd have them to the second stage. So you'd have 8 of the cones complete, ready for the next one, for the larger cone. And it's actually the same process there. So it's just mixing the stuff. As Mike said, it's beneficial if the iron filings that go in the outer cone are slightly larger. The ratio stays the same, Mike, doesn't it? It's about 30%.
Yes, sir.
So it's possible to add slightly bigger material for the outer cone, and they're just cast in the same way. So the same process as with the middle cone. You get the DPM polythene and you just form it, and then again you have to take into account the displacement of the of the second cone being pushed into it. So you know, you
Not to-
have to leave it so that the level that that it's lower down, and you need to, with the outer cone, you need to just agitate it a little bit to make sure that you've got the best possible surface. And then you find you can tell the consistency of the material by whether or not the second cone will kind of float in it. Because if there's too much water in the mixture, then the second cone would sink into the third one. Whereas if it's the correct mixture, it tends to just kind of float, or it sort of bobs up a little bit. Sometimes you need to put a little weight on just to kind of push it down. And as Mike was saying, getting it beneath the surface, that's another little way to enhance it, really.
Yeah, you can make a bit of stiff stuff and put in the bottom that accepts the stiff concrete.
Yeah.
And you put that in the pointy end, and then the pointy end of the other one won't sink through it. Then you can put the loose stuff around it.
Yes.
And yeah.
Yeah. If it's pourable, but not stiff, then it will take the weight of the cone, and it's quite easy. You'll find after you've done a couple of these mixes that it's fairly easy to do. I haven't I've not actually lost any of the cones as a result of the mix not being correct, because you just have this intuitive feel as to it being the right mixture. Because if it's too wet, it's sloppy. If it's too stiff, then it won't go into the shape of the mold correctly. But so at that stage you'd have the outer cone, so that's formed, and you just put the outer cone into one of these large glasses, and just make sure that as it's setting, just look at it from both angles to make sure that it's level, because you want it so that as it sets, the base of the cone is level. If the cone isn't level in the jar, you'll find that you get a bit of an angle, and then the cone wouldn't sit upright.
I got an idea here for your cones and painting them. If you painted the bottom, and then set it on cling film, it's going to glue to the cling film, obviously.
Yeah.
Will the resin set up underneath the cling film? Should do.
It doesn't really set. The resin needs to be in the open air to be able to set effectively.
Okay. Yeah.
So that's why it's preferable just to do the outer edge of the three cones and leave them outside, and then you find that they'll be dry within 24 hours. And then to actually to paint the bottom of the cones, what I do is I lie the cone down on the table so that the base is visible. But because you've actually coated the cones and they're in good condition, then you need to kind of wedge them so that they're apart. So if you were going to coat the bases of, say, 4 cones at the same time, then you need to just wedge them and keep them apart, because if they bump into each other, they can chip. So you need to just make sure that they're use some little wooden wedges or something just to make sure they can't bump into each other. And then you just you do the 4 bases at the same time then.
It might be an idea. I don't know if this will work, but after you get the amplification layer sets up, if you just put 1 layer of cling film on it and hit it with blowtorch so that it turns black, Okay, it's real quick.
Yeah.
It creates a nano coating, and that nano coating is the same thing as GANs. Okay, and now the problem with these nano coatings is that they fall off easily. You know, but for the first two cones, encased in concrete, ain't gonna go anywhere. It's gonna stay.
No, exactly.
So the only if that's just be another trick, and more spin energy. Basically, that's the nano coating creates microtubules in the carbon, and that leads to herself in darkness. That's why nano coating. You nano coat a piece of metal, and it will actually draw electrons out of the air into the microtubules that are the same size as DNA. And the way that you know that is because they're superconducting. And so the electrons will go to a superconductor before they go to ground. So they'll go into the DNA spin of the nano coating or GANs or the piezoelectric energy that we create. And that they then are converted to photons. Because that's what flows in a superconductor. And then it comes out the other end and it runs into another conductive material and has to convert back to electrons. And so you get a continuous production of electricity. The nano coating metal, like I say, it then produces a little bit of electricity forever as long as maintaining the nano coating.
Fantastic.
And that's saran wrap, you said, Mike.
Yeah, any kind. Just really thin plastic, doesn't take much. You don't want to have to heat it for very long or anything. Just hit it with a blowtorch so it goes black. Because otherwise, you heat it too long, you may hurt the resin underneath it. We're putting it on resin as opposed to this is something that you want to see if you can do it, and also see if you can feel it. Obviously, I mean, David, it should be easy. Your pine cones are quite powerful. And so you just try it once on one of your pine cones, you're going to tell right away whether this is a useful trick.
Yes. Yeah, I've not tried that, but I've not had any problems with any of the structures. Doing it in the way Mike advises in his paper. The cones actually adhere really well, so there's been no breakdown, and the screw-fix rapid setting cement is very strong, so you shouldn't have any construction problems really. They do stick together. Does anyone have any questions?
Yeah. Mike, would it be a good idea to put GANs in the resin coating when you're mixing it up?
Not really. You know what happens when you put GANs and GANs water and resin? It becomes more like plastic, and you can and it doesn't set up. It's really quite amazing. Doing that. There's a guy that does do that, and he can make literally plastic forms that are flexible. So the GANs doesn't set up and get stiff like we want it to do. Because then you get the squeezing effect on whatever's in there.
Okay.
Yeah, the resin is spirit based, so the water wouldn't be compatible with that really.
Yeah, right.
Okay, so I've got I've been just gathering information about how other people are building these cones, and there's a lot to do with the consciousness you imbue them when you're making them. You should have that right frame of consciousness. Also to play 33 hertz music or tones. And things like that in the background. Also to give each cone a name and create a connection with each cone. And I really resonated with that when I was reading. I think there's these people in Arizona that are building the triple cones. And they play music to it. Sometimes they chant to it. Whatever your way to communicate with them to imbue your consciousness in the cones. So I know this may be going out to people that aren't so much into that, but I would suggest just get the right kind of music. We're now creating a body of music with the Merlin's trance music that can be played as these are being constructed, because you're creating an entity with these cones.
Yeah.
I
That's
just want
right.
to say
Yeah.
something about those frequencies that I believe the numbers are correct, 528, 33, etc. But those numbers come from a time when the second was not the measure of time, but the helic was the measure of time, which is 3.333 seconds. So I would say that 528, if you divide by 3.333, becomes 316.8, which is 31680 is the perimeter of the Earth. It's all in miles. It's also the perimeter of the circumference of a circle where the moon is resting on the Earth. So this is a significant number, and it's the 11th harmonic over frequency that I found to be part of the electromagnetic frequency of the day as a B flat. So 528 is the right number, but it's not hertz. So if you're going to do it in hertz, it's 316.8, or instead of 33, it's 9.9 vibrations a second.
Yeah. Great, thank you.
Yeah, three is boggles my mind, because it's the only electromagnetic vibe that can flow in a capacitance field. You know, and no other frequencies exist in a capacitance field because there's no toroid formation. And so the three has to come from the triune, the three gods, or three quarks, or whatever. You know, you got three quarks and protons and neutrons. You know, and
well, Mike, you were talking about spin as well, and you know the helic is a measure of the rotation of the Earth. It's 1/72 of a degree of turn of the Earth. So 72 is a significant sacred number. So the second is like this medieval invention. I was just checking it this morning. So you know, if you're talking about rotation and those sort of things, you know, 72,
yeah,
3,
everything spins due to the rule. I am that I am. And so, but this three is mind-boggling to me. You know, I mean, it very much appears to be the carrier wave from 2D, four-sided ethers, world of images, the quantum, if you will, into our material universe, which manifests in hexagonal ethers to start with, and then also eight-sided ethers as you get into planets. You know, they're in the eight-sided ethers. But you know, so we're working with the ethers as much as we can. We got to recognize that they're there. That's the biggest detriment of science today, is that they don't work with the ethers. You know, if they did, we'd be so much further down the road. You know, because it's not difficult; it's really simple. But anyway, they are. Einstein said the ethers didn't exist. So, I mean, you like Pollux water, the fourth to fifth phase of water. It's all in hexagonal patterns. Excuse me. Maybe you could come up with a reason for why it's a hexagon. They never mention it. They don't even come close. It's like, what?
Great. So any more questions or? Okay.
brilliant.
Hear me?
Yep.
Yeah. Got a question for Mike. It's a bit of an advanced question because I'm trying to max out my cones. So I've got this idea for the small quartz crystal inside the pine cone. I've managed to find a couple Vogel cut quartz crystals that are about 4 centimeters long. And I'm wondering, so there's this idea, if you put piezoelectric pressure on a Vogel crystal, it will make its life force amplification power a lot more powerful. So I have an idea to like wrap wire around it and then have the wire come out the top of the cone, something like that. So Mike, what do you think about that?
Yeah, I would put that wrap crystal underneath the goodies, So it's pointing into the goodies, you know, and carrying spin energy into the goodies, and wrapping it with copper wire is a good idea. You can take that copper wire and come out of the cone, and it can come all the way out, you know, through all of the cones, and hook it up to a violet wire run.
Yeah.
That's not a bad idea at all. You know, yeah, and then you know, 4 centimeters is a bit long. You only need, you know 2.2 an inch max. You know,
Well,
and then you
the
have a
issue
little
is
bit
it's
of
really hard to buy short Vogel crystals. Like the smallest ones I found are 4 centimeters long. But I'll do some more digging there.
I've had lots of them. You know, I got a whole bag of them here. You know,
But is there
they're cheap.
Vogel cuts
They're clear.
there?
Clear. Well, this no, I just get regular, naturally shaped, you know, clear quartz crystals, reasonably clear.
But
And
if they're
then,
cut at these specific angles, they're considerably more powerful. Have you
okay,
heard
well,
of
if you want to do
Vogel?
that, you know, what's his name? You know, if you want to get into that, you go into Marcel Vogel's crystals
Yeah,
that are cut with
that's what
Yeah.
I'm talking about.
Oh, okay. All
Yeah.
righty. Yeah, of course. Those are, well, the other thing that he did was he shaved with the laser, he shaved off the sides of the crystals also, because when they're growing in granite, which they grow, they get a stress layer around the outside of them. And so he cuts that off. We don't worry about that because the euphoria of the capacitance field eliminates that stress almost immediately. You know,
All
but
right.
properly cut, like you're talking about, that's going to work quite well.
And if it's 4 inches, that it shouldn't matter because it's properly cut. It doesn't matter that it's that big.
Run that by again.
I meant 4 centimeters.
Yeah, it doesn't need to be that big. What I've found with the natural quartz crystals, you just you just take a little clear quartz crystal, you know, it's kind of like almost like a shard. You put it in your left hand, and it'll almost like burn a hole through your left hand. You know, you can feel it. You know, those are the kind of crystals I like. And then I take graphite and a little dab of honey. The honey being having a hexagonal matrix forces the graphite into graphene, you know, which is 2D, which is a connection to God, you know, herself and darkness, you know, because it's made out of carbon. And you put the little tiny bit on the truncated end of a natural quartz crystal, and you can feel the power of it. I mean, it's amazing, you know. And you put that underneath the goodies because it's going to keep going forever.
Okay. Yeah. Cool.
That's much easier and it's cheaper, you know, than buying the other ones. They're, you know,
Well,
if you
I'm
want to,
trying
that's
to
fine.
max it out. So, you know, trying to make it as powerful as possible.
Okay.
And
Oh.
the difference between amethyst and clear crystal, it sounded like in the goodies you want both. What's the difference between them?
Amethyst is a cleansing crystal, and as when you get, this is what's his name, Carl Welts is really a good organite. He invented the name organite. What he talked about, and his devices are very powerful, is to never have anything over the size of a grain of sugar in any of the pieces. But the problem with those really, really fine pieces is that they clog up with information. It doesn't travel, it doesn't move out. And the amethyst, apparently, amethyst and citrine move it out, causes it to keep moving.
Cool. Okay.
Okie dokie.
Great, thank you.
Brilliant. Thank you, David. Shall I
Yeah.
stop recording then?
Yeah, certainly.
All right.